Okay, so in this video, we're going to test for this series, whether the series is convergent or divergent. Um, let's do that. So this is going to be a situation where we will probably use the um, root test because there's a lot of like nth powers here and like I can immediately see what's going on. So let's go ahead and jump to it. But before jumping to it, I'm going to just quickly tell you that the limit is going to not equal anything other than 0. So it's going to equal 0. The limit as it approaches to infinity. You can try to test that on your own, but it's going to essentially get to 0. So we can't use the divergence test here. So I'm going to jump to the root test here just to save some time. What the root test says is the following. So if we take the limit as n approaches to infinity of the nth root of the absolute value of a sub n, and if this is equal to, so this is equal to some L, and if this L is less than 1, then it is convergent. The series is convergent. This is scenario 1. Scenario 2 is if this limit is greater than 1, which would show divergence, and if this is scenario 3 is if this is just equal to 1, which would be inconclusive. So let's see what happens. So, okay, I'm going to rewrite this. So let's just go ahead and write this. So limit as n approaches to infinity. So we can take the absolute value of all of this. We don't need the absolute value because as we approach infinity, it's going to be positive. So I'm actually just going to exclude that here. So it's going to be 4n plus 1 raised to the nth power divided by n to the 6n. What I can do is I can take these n's and I can write them all, and I'll do that in the next step. So we can write them all as 1 n power. So I raise this to 1 over n. This is equivalent to making this nth root. It's just, instead of that's kind of messy, let's just make this 1 over n. Same thing. Limit as n approaches to infinity. What we'll do here is we'll take this n. So we'll take an n and we will write it. Okay, maybe I'll do this. N to the 6th, and then all of this raised to the nth power, and all of this raised to the 1 over n. So it's kind of beautiful how this goes away and becomes 1, and so we end up with the limit as n approaches to infinity of 4n plus 1 over n to the 6th. Now it's not so bad after all, right? At first it looks so daunting, it's kind of scary, but now it's just a simple problem. So this is going to be, if we divide this through, it's going to be 4 over n to the 5th power. I'll just do this quickly because it's just a simple limit problem. We don't even need to do all of this, but if you wanted to, because this will go to 0, this will go to 0. So this whole thing ends up being 0, which is, of course, not equal to 1, so we're good. But this is less than 1, which shows us that it's absolutely convergent. It is absolutely 100% convergent. That's not what absolutely convergent means, but it's absolutely convergent, but we just care that it's convergent, and so it's convergent. Well, technically, absolutely convergent does mean that it's absolutely convergent, like it's 100% convergent. It's a stronger convergence than just saying it's convergent. So it is more definite that it's convergent. And there's other implications of absolute convergence when we think about like rearrangements and stuff. But yeah, this is the problem, convergent, and we can say by the root theorem or the root test. That's it.